Okay, hello everyone. We're going to discuss lesson 6A, the descriptive statistics for DATAENG or engineering data analysis. Basically, during class, hindi na ito din-discuss, but for the purpose of your synchronous class, you can watch this video. So we'll discuss the numerical summaries of data, the stem and leaf diagram, the frequency distribution, and the histogram, the box plot, the time sequence plot, and probability. So basically, this is just an overview. Let's discuss a lot of calculation. So it's up to you. You discussed this already in your statistics in high school or in the foundation stat that you take. So this is chapter 6, or the descriptive statistic of the textbook Applied Statistics and Probability for Engineering by Montgomery and Runger, the 6th edition. So, data are often being collected either from the population or the sample. When we collect data from the sample statistics is the one that we are getting. Well, if it's from the population, it's the parameter. So, samples is the part of the population where you do analysis at random. Basically, we want to present the data in terms of easily understandable presentation, either by numerical or graphical method. So this could be a sample data or the population data, but mostly sample data. And we describe the data as SOCS, or the shape, the outliers, the center, and the spread of data. The center measurement is usually measured by mean, and the spread is usually defined by the variance of the sample or the standard deviation. So the sample mean is just the average of all the sample data. So you just get the sum of the sample, divide by the total number of sample. While the population mean is just the probability distribution of the total sample. Okay, so total sample siya, or total population. So we note population mean as mu, and we denote sample mean as x bar. Okay, so this is a sample of the sample mean calculation. You just get the sum of all of this 8 sample and divide it by 8. So divide nyo by 8. Okay, ito yung data niya. I think this is the pool of scores data that we have on lesson 1. And the mean value is 13, so around this region for the dot plot. Okay, now variance on the other hand is defined by the sample variance by this formula and the population variance by this formula. Take note that this is the square of the difference between sample and the mean data. Get the sum and divide it by n minus 1. While for population variance, the same, sample minus the mean value of the population, square, get the sum, divide by n. Yung n minus 1, later we will describe why the sample variance is n minus 1 while the population variance is n only. Okay, now, standard deviation is just the square root of the variance, and the symbol is sigma. So, S for the sample, standard deviation. This one is for the population. Okay, so you know already how to calculate the sample variance, either in the calculator or sa Excel. So, you just apply this formula. May shortcut siya. You can use this expression, yung shortcut na yun. So, square ng x value or ng data mo, sum mo yun, minus the sum ng all data square divide by n, divide by n minus 1. Okay, so ito yung sample. So, pareho lang siya nung data dito. So, standard deviation, tsaka yung variance. Okay, so ito yun, yung standard deviation and the variance of the sample using the second formula. So you can utilize this formula. Okay, now, why n minus 1? Take note that the mean of the sample is x bar. And this one is an estimation of your population mean. So, this is either close within the mu value, within a specific range of value, so that we want to eliminate the error by dividing n minus 1. So this one is to compensate for the error in the mean estimation. Okay, the sample variance is calculated with the n minus 1, which is what we call the degrees of freedom. So degrees of freedom, this is just n minus 1. The n minus 1 data of the observation can vary determined, but the nth observation is fixed to maintain the zero sum. Okay, so basically, yun lang yung degrees of freedom mo, n minus 1. Depende yan sa type ng samples or data. Okay, now, for sample range, so yung sample range mo, if you have an observation of n, observation from x1 to xn, the sample range is just the distance between the maximum value or the largest value minus the minimum value or yung smallest value. Ayun lang yung range. So, population range could be greater than or equal to the sample range. Okay? Now, how to construct stem and leaf diagram. For stem and leaf diagram, so basically you're familiar with the dot diagram. But if you have a large data and you want to have a better observation or presentation, you can use a stem and leaf diagram. Stem and leaf diagram. So, yung construction, you can divide each number into two parts, the stem and the leaf, which is the digits usually. Ito yung leading digits, ito yung remaining digits. Then list the stem value in vertical column, either decreasing or increasing. Record the leaf for each observation beside its stem. Write the unit of the stem and leaves on the display. So, paano siya ginagawa? If you have this data, this is, I think, 1, 2, 4, 6, 8, 2, 4, 6, 8, 10. 10 times 8, that's 80 sample points. And if you want to construct that diagram na nasa linear, medyo mahaba yung spread na gagawin mo. So, better do a stem diagram. So, ang gagawin natin, for the stem, ang kukunin natin is yung 2 digits, yung hundreds at saka 10. Then, yung leaf natin will be the ones digit, yung ito. So, ngayon ko lang ha, erase. All. So, for 105, saan siya papatak? So, ito yon 10, yung digit niya, then ito yung 5. So, 105. Yung 221, ayan, 221. Then, you just write yung number dito. Then, yung frequency, bibilangin nyo lang. So, 1, 1, 1, ito 2, and so on. Ito, 12 to, ito 10, ito 10. And from there, you can highly see na most of the data are from here to here. And the mean value will fall between this data. Okay, yung mean data. Okay, now, quartile. For quartile, this is the dividing the total number of data into 4 equal sections or segments. So, first or lower quartile, this is 25% of the data. Second quartile is that 50% of the data is less than the Q2, the median. And the third or upper quartile is 75% or Q3 data. Then, yung nasa taas ay yung 25% na portion. So, basically, you need to get the frequency of that data. Okay? For example, here, kailangan naka-arrange ang data nyo in order. So, ito, kailangan nyo pa itong i-rearrange. Or ito, i-arrange nyo siya in increasing or decreasing order. So, basically, increasing order, yung pinaka mabilis. Okay? And from there, you can calculate for the index. So, ito yung formula niya. You just multiply it by 0.25. So, this is 143 to 144. So, average lang siya, 143.25. 160, 163. Andito siya, yung ayat at saka ayat 1 plus ayat. So, 163.5 and 165. So, basically, kukunin nyo lang yung data. This is quartile 1, quartile 2, and this is quartile. Now, IQR, or the interquartile range, is just the distance or the difference between Q3 and Q1. So, for this case, ito yung Q3 natin, 181. 181. Ito yung Q1, 143. So, 37.8 yung IQR. IQR will usually dictates kung ang isang data is an outlier or not. Okay? IQR is not affected, range is directly affected. Bakit? Pag range kasi, it's the maximum and the minimum data. While for IQR, it's on the quartile. Or you remove yung maximum at saka yung outlier na data. Okay. Now, for the Minitab, you can have this one, stat basic and display. You can have the minimum, the median, quartile 1, quartile 2, at saka max. Sa Excel, pwede din yan. Pwede nyo din yung kunin. Okay, so basically, this is just the 5 summary data. Okay, may mga function din to sa Excel. So, you can utilize Excel for this data. And you can also use your calculator. Now, the frequency distribution table, or the frequency distribution. Yung frequency distribution, this one is just a summary of data expressed as table, graph, or function. Basically, you just compartmentalize or put it in a cell or a bin in a class interval. The number of class is basically just the square root of the sample size as a guide. And the boundary of the class interval should contain int value, as should the class width. Okay, so, sample tayo. So, basically, yung data natin kanina, yung, ito, data na to. So, we have 80 data, 80 sample. The minimum is 76 and the maximum is 245. So, from that data, we know that the range is from 245 to 176, to minus 76, so 169. Yung sample natin is 80. So, if you get kung ilang compartment or cell, ito yon, you just get the square root of 80. So, from here, square root ng 80 is 8.9. So, you can have 9. For the class width, trial class width could be 18.9 na value, or i-divide mo to ng 9. 169 divided by 9. Okay, or that's 18.7. 169 divided by 8.9. So, 18.9. Yan yun, 19. So, from there, we can have the class width as 20. And the range of class, so multiply nyo lang, 9 times 20, so 180. So, the starting point, yung convenience, 70 to 90. So, by tens, yung value, or for this case, by 20. And from that range, you calculate kung ilan yung value will fall on that range. So, from 70 to 90, ito, dalawa. So, you can use the leap diagram. Ito yan. So, and so on and so forth. And relative frequency is just you add everything below that value. For example, here, divide by the total. So, ito naman, ito divide by total. Ito divide by total. So, ayun yung relative frequency. Yung cumulative frequency, you just add this one. Okay? I-add mo lang yan. Tapos, ito yung value niya. Tapos, add mo ulit ito. Ito yun, and so on and so forth. Until ang maging total niya ay 1.0. Okay. Then we can represent our data, especially the cumulative frequency or the frequency table or the frequency data as histogram. A histogram is just like a bar graph, but it's just a visual display of frequency distribution. Ang bar graph kasi per category or per data siya. While for this one, this is a frequency. Okay? Step to construct. So basically, aralin nyo to sa Excel. Kaya na yan. Okay. So basically, here is a histogram of table of your compressive strength. So basically, ito yung nasa frequency distribution natin. Ito yung ranges nyo. Ito yung frequency. Usually, you can adjust the bin of the data. So, pwede nyo yung baguhin. Okay, so this one is an adjusted bin. Ang ginawa, ay in-adjust siya to 10 ata. Tama, tagte 10 to. So, this is 70 pa rin. Tagte 10 yung frequency. So, as you can see, hindi na siya mukhang normal distribution. As compared for this one, may normal distribution. So, basically, this could be caused by too many bins created. That will make the shape of your plot not normalized as we want it to be. Okay? But, for cumulative frequency naman, mas madali naman ito. Pwedeng kahit ano yung bin niya, pero you can see the shape. Yung S shape, we call that S shape. And this frequency provide the information on yung cumulative data. And makikita mo kung saan yung steepness. Meaning, doon dumadami yung amount of data frequency. Okay? Now, for shape of the frequency, usually we just have the symmetry or the skewness. Pag skewness, we have the positive and the negative skewed data. Pag negative skewed, left skewed, pag ganito siya, papunta sa left. Pag positive, right skewed, papunta sa right. Pag symmetrical, meaning equal yung distribution. Okay? Now, for categorical data, you can also use histogram. However, medyo problematic siya in terms of kung wala kang value, okay, na i-assign for your ordinal data. So, basically, yung ordinal data, meron siyang natural order. So, either you can arrange it from increasing to decreasing order. While the nominal naman, for categorical, medyo difference lang. Okay? So, histogram bar are for each category are of equal width and have a height equal to the category's frequency or relative frequency. Usually, we do Pareto chart where we arrange the parameter or the frequency in decreasing order. Decreasing order siya. So, ano itsura niya? Ayan. So, from here, makikita nyo that majority of the data, this one is airplane production, is the 737 and 757 model, yung data. Okay? Another data presentation na I advise that you study kung paano gawin is the box plot or the box and whisker chart. So, basically, dito makikita nyo yung center, yung spread, yung shape, at saka yung outlier. So, it displays the 5-number summary, the mean, the quartile 1, the median, the quartile 3, and the max. So, ito yung quartile 1, ito yung quartile 3, ito yung mean, this is the mean, median pala. Median, ito yung minimum, ito yung maximum, ito yung IQR. Okay, ito yung IQR. Okay. Now, kung ang data nyo ay from the first quartile and the third quartile marks ranges from 1.5 IQR, within the 1.5 IQR siya na data, then you can say that they are not an outlier. Pag more than that data, you can consider it as outlier. Pag greater than 3 na, yung layo ng data nyo ay greater than 3 IQR from the first or the third quartile, then you can record it as an extreme outlier. And the data here will be the smallest data point within the 1.5 interquartile range from the first quartile. Ito yung magiging end ng whisker ninyo. Okay? Now, so, box plot of table 6-2, ito yun. Yung 181, 161, tsaka 143. Ito yung outlier natin. Nakikita nyo kasi may IQR tayo. Ang IQR natin ay 143.5 to 181. So, yung distance na to, multiply mo ng 1.5, ito yung IQR from the quartile 3 and quartile 1. Okay? So, lahat ng nagpass dito ay we will consider as outlier. Okay. Now, for a time sequence plot, basically, it is plotted against time in increasing order. Okay? Increasing siya. A time series plot shows the data value or statistics on the vertical axis with time on the horizontal axis. So, ito yung statistical data. Ito yung time data. So, a time series plot reveal trends, cycles, or behavior in time. Okay, so basically, ito, trend increasing. Ito, may cycle ka that second, so basically, second quartile ay nag-i-increase yung trend. Okay? So, digidot naman is combining a time series plot with some of the other graphical display that we considered previously will be very helpful. So, ito yung steam plot. Ito yung digital plot in the time series data. So, meaning, these data are collected in with respect to time. Okay? Constructing a probability plot. To construct a probability plot, basically sort the data observation in ascending order, increasing. The observed value, xj, is plotted against the observed cumulative frequency, j minus 0.9, and the paired number are plotted on the probability paper of the proposed distribution. If the paired number from a straight line, then the hypothesis distribution adequately describe the data. So, ipa-plot nyo lang yung data nyo at saka yung probability. Ayan yun, like probability plot. Okay, yung frequency. So, basically, pag probability plot, may linear. Dapat magli-linear siya. Para siya ng linear. Okay? So, ito yung sample. Ito yung normal probability plot of ordinary axis. Okay? Probability plot variation. So, basically, pag light-tailed, nagtitail siya, yung distribution mo, pwedeng non-normal siya. Pag heavy-tailed, basically, pareho lang yung ano mo, dito naman siya. Malapit na dun sa linear. While right-skewed, paganto yung plot ninyo. Nasa baba halos yung data. Okay? Now, probability plot with Minitab, you can have this one. Meron din sa Excel nito. So, you can try the probability plot. So, I'll teach you pagdating natin sa linear regression. Okay? So, ito lang yun sa Minitab. Okay? We end our lecture here and